Welcome everyone to the next edition of the eVTOL Writers Group interviews. Today we have a really exciting interview for you with Dufour Aerospace. Exciting things they've got going on, and I'm really I think you'll find this a really good presentation. I know I've looked at it a little bit, and it's going to be a great interview. So today our moderator is Nicholas Zart. He's a contributing author for Vertiflight, eVTOL.news, and he's been covering electric aviation for about 15 years now. Or I should say electric transportation for about 15 years now. So this should be really good. So with that, Nicholas, I'm going to turn it over to you to kick things off.
Perfect. Well, thank you. Thanks, Jim, for this introduction, and hello, everyone. Today, I'm really excited to talk about Dufour because I've been following these guys since 2015, and it was the first company that just made me think, wow, electric aviation is here to stay. Thomas was introducing a little electric airplane with, at the time, a Siemens electric motor, and it was only for acrobatics, and I thought, wow, this is fantastic. Any training school can get into that, fly for a half hour, pennies on the dollars. This was just perfect. And then nothing for 5 years, and I thought, uh-oh, what happened? So I reached out to him about a year ago, and he said, hold on, we'll have good news in a few months. And so I waited, and then the good news happened. So I'm not going to spoil the good news. I'll let you talk about it, but I'd like to introduce Thomas Pfammatter, who is the CEO of Dufour, and is one of those rare people who actually has experience both in an airline management, and he is also a helicopter pilot. So he really knows what the industry is about and what the industry really needs. And he is with Jasmine Kent, who is the CTO of Dufour, who also has a fantastic background with Google, but mostly who co-founded, am I going to be able to pronounce it? Diddling. So, and I'm not going to butcher any more names any more than that. With that, Thomas, take it away. Thank you.
Well, thank you very much, Nicholas. I'm happy to be here as well to explain you a little bit about what we do and where we come from, yeah, as well answering as many questions as you can get. So thank you very much for the invitation. I guess I should probably start first with a little bit with a presentation, I would say. So if you could maybe go to the next slide. So the Dufour Aerospace, as you rightly said, Nicolas, started almost 5 years ago. Dominic Steffen, the one on the upper left side, and me started to think of electric aviation because we were very aviation affine. He's a test pilot for paraglider. He was the world champion in aerobatic and paragliding. He did test piloting hundreds of paragliders and as well a couple of aircrafts. And we own a Yak 55, an old rail engine aerobatic aircraft. And we said, well, the time is ready for aviation, for electric aviation. And so we started this project. Nicholas already introduced, and Jasmine as well. And in between, we could gain a great team. Beside of me, it's Simon Bendre. He's actually I would say one of the most experienced aviation developers you can get. So he did all the wings of the Airbus aircrafts, or was helping or leading developing all the wings from Airbus 300 to 350, up and down, all kind of other things. And as he was as well the head of engineering of Aeromobile, that was another startup, and joined for us. So he's the head of design of our company. The next one is Manuel Flepp. He did develop the whole SH-09 Kopter helicopter. He's a composite specialist and knows how to develop these kind of aircrafts. Danjan Hieger, beside of Jasmine, he's our test pilot. He's probably the one who flew the most electric planes in the world, including Solar Impulse, Solar Stratus, volocopter as well, and will as well test ours. And then the Felix Rubin, the third one in the row, he started very early with us. He's a genius aerodynamicist who did develop the whole transition behavior of these aircrafts based on our existing or our baseline. And the last one, but not least, is Thomas Zeiler. He was actually the head of electric propulsion of Solar Impulse SI2. So he did develop and design the aircraft, the electric propulsion system of the aircraft that flew around the world. So he is probably one of the most knowledgeable persons in the world about electric systems in aviation, and especially if they have to be fail-safe, because you fly 5 days and nights above the Pacific. So as well, he is a great adding to our team, and that's basically the leadership team of Dufour Aerospace right now. Maybe next slide. So that's where I come from. I'm still, and you see that I'm still here. So I'm actually on the helipad of a heliport in Zermatt of Air Zermatt. So I do that since 25 years, flying these choppers, more than probably 11,000 flight hours helicopter and more than 3,000 rescue missions. I still fly that regularly, so to keep up my licenses. And that's basically where our expertise comes from. So instead of just building technology, we have the approach of how do you use these aircrafts today, and where and actually how is this going to lead to electric VTOLs, and so we decided first we have to develop the technology, and obviously first was the electric propulsion system. Does electric flight really work out? And I was the biggest piston head in that game, so I said, yeah, why, right, electric propulsion aviation, nice, maybe for a glider plane, but that's not really going to work until my friend Dominic convinced me that we should build an electric aerobatic plane. That as well is obviously one of the most usable applications for electric propulsion. Why? Because you make noise at the same place, not just for takeoff and landing. You have usually very small flights, so not more than a half an hour, and after you're anyhow kind of happy to land again. And yeah, you need a lot of power for doing that. And that was our baseline: make an electric aerobatic aircraft that can not just fly 5 minutes or 10 minutes, but do actually fly 25-30 minutes aerobatic flight, and then having another 15 minutes reserve on a regular airfield, such that you can basically land or go around if something happens in a regular airfield. And that led to our first project. We started in 2015. Maybe next slide. That's this beautiful aircraft here that we built and tested, and actually it flew so well that we did within 6 months about 70 flight hours. At that time, other than glider airplanes, we were belonging after these 6 months to the team with the biggest electric flight experience in the world. So more than Boeing, more than Airbus. There was only Pipistrel who had more at that point. And actually we could test this aircraft in our mountain valleys at 30 degrees Celsius and as well at the end in December at -10, and we flew it up to the Matterhorn as well, so up to 13,000 feet, and did all the tests. And actually this is the first aerobatic electric plane that we
should we roll the video and then we could kind of talk a bit.
Yes, exactly. Maybe we can show the video of that quickly.
Our home base, Rowan Airfield. You're muted, Thomas.
Yes, exactly. Sorry about so that's Dominic in the Rotterdam Air Base. That's our valley where we fly, and it was sponsored by Hamilton and Siemens. That's obviously why the names are on it. And we could fly it up to eight flights a day. So the one critical element in electric flight is this. It's called the delta T. So the batteries that heat up, and at a certain point they're too hot to go flying again, because every flight adds temperature. And with regular temperatures about 25 degrees Celsius, we had a delta T of 0, so we could basically fly the whole time, and that's what we did. We flew half an hour aerobatic, and then we did recharge it the half an hour and go flying again. So this is kind of how we did. And yeah, the first time that you fly electric planes, that's maybe one element of this regional or urban air mobility that the people can't yet realize, because that's not happening yet. But it's actually super cool to fly electric planes. It's way better than everything I have ever flown. So it's like a glider plane with aerobatic power, and you have as well exactly this experience of a Tesla. So instant acceleration, and that's, by the way, as well, the first flight I did unintentional, because it accelerated so fast that it was in the air before I even realized that I'm in the air. And so that as well led, yes, to our decision. We can really electric propulsion making a reality as well for VTOLs, because that's about the same kind of application. You need a lot of power to take off and land vertically. And then we started to think about the concepts, and the concepts. One lesson we learned is that efficiency obviously is very important. So if you have a conventional helicopter or a conventional draggy aircraft, electric propulsion will not suit. So you have to have something that is able to compete or to be very efficient. And we didn't want to develop anything new, because we thought we have to check what is existing, what already flew that way. And then maybe next slide. We found actually existing convertible aircraft, and some have a very bad reputation, like the V-22. But the other side, the CL-84 of Canadair had actually a fantastic reputation and turned out very well in his flight behavior and how it flies, how it transitions. There were about 50 pilots flying it, and we did basically then realize that this is the concept to go, because it's very efficient in hover, because the props are big and not small, and it as well has a wing and not much drag from any outstanding lifting props and so on. So that was our baseline that we went, and we started to simulate everything. That's why Nicolas, the 5 years passed as well. So first we wanted to be really sure this is going to work. So we don't want to show, yeah, that's a great concept and it doesn't work, but rather first we want to develop it. And the first thing is Jasmine started to simulate all this data of our aircrafts and see if it's working. And the second part was then obviously developing the control system, because obviously on a convertible plane, the control system is quite critical, as you can imagine. So that was a time where we started to develop, or that led to the time where we simulated, developed, and finally proved with our VTOL demonstrator that this is feasible. Maybe next slide. Now I give over to Jasmine. She can tell a bit about what we did there.
Yeah, so this is our largest tilt wing so far. We started a couple of years ago with smaller scale models, and we built this one last year and have been test flying it this year. We call it our VTOL Demonstrator. It has about almost 4.5 meter wingspan, and we've done a flight test program so far over 500 flights, and we've been able to really prove all of our models and our simulations, and yeah, demonstrate that we really do understand the aerodynamics of these aircraft. Actually, it was quite nice to see that actually the simulation model that we've been using was too conservative, and in fact the performance of this aircraft has been even better than we expected. Let's roll the video of our test flight campaign. Ta-da! So yeah, that's what we've been up to this summer, and we are using the data from this project to feed into our design program for our flagship project, which is Aero 3. It's a large manned tilt-wing aircraft. It will have 5 to 7 seats, and we're designing it for the medical transport market. Can we go to the next slide, please? Oops, hang on, I'm not synced up yet. So here we have a concept rendering of Aero 3. This is from last year. The concept or the design that we have now been fleshing out is actually not quite the same as this, but we're still making sure that we've done all of our homework, and that what we have will really be meeting the operational requirements of EMS air operators, and also certifiable under SC VTOL. So this is the approach that we want to take, like do our homework first and then show it. From Thomas's background, we really understand what these operators need to have in their aircraft, and we believe it makes sense as a path for entering the market. if we go to the next slide, it's a good illustration of the maybe we should have put this slide later.
Doesn't matter. I mean, we can quickly explain. So so we are a firm believer in urban and regional air mobility. We're pretty sure that you can build up use cases that are far more attractive as they are today. But what we believe, or what I believe as well, especially, is there are a lot of hurdles in this new future markets, and that's where I see the potential for us. So we are designing aircrafts that are usable for today's operations, that are usable for today's operators. I would like to have an aircraft that is kind of plug and playable into this operation of a regular helicopter, and we don't have to go too far away from new and potential markets. We just have to take or analyze these ones that we have. And I was, by the way, as well, 15 years the CFO of Air Zermatt, so that's basically operational, my operation knowledge. We are constantly looking for business models, business cases that we can use in helicopter operations. And actually, this is it, right? So if you have an aircraft that is 3-4 times cheaper than today's helicopters, you don't need a lot of other new kind of markets that open up, because the amount of people or operations that become affordable are dramatically increasing. And the first, obviously, is EMS transportation. As we save so much time from hospital to hospital, as we have the infrastructure on hospitals, so almost in the Western world, all hospitals have helipads. So you just basically can operate these aircrafts from hospital to hospital. And if you just take these flights and these operations that are today done by ground transportation, it's about 1/3 of all ground ambulance transports, and you provide a more efficient solution, then you already increase the demand of helicopter operations by factor 10 to 20. So I will never ever be able to even supply all this amount of planes to just support that part of it. So I don't need even urban air mobility at that stage. I just want to make sure that these aircrafts are usable for today's helicopter operations, that they are as well understandable for today's pilots to fly, so that they can basically fly them like today a helicopter. And that starts with the visibility, that continues with the way you operate, like you have your 5-minute takeoff power range, electric, and then you have your continuous power range for cruising. That's pretty much the same in these kind of aircrafts that we build. And you have to make sure that they are rock solid and have enough space to include all the needed tools in for this kind of operation. So we are kind of more traditional into this industry, or we start with that. We want to transfer or change the way today's helicopters are operated, and we believe we will build an aircraft that can take over almost 80% of today's helicopter operations. There are a few who will still be done by helicopter. Give an example, sling loading is a typical example. That's way more efficient with a helicopter. And as well, if you have to go rescuing people out of a mountain at night with a long line, then you probably prefer the helicopter. But the vast majority of potential is hospital to hospital flights, or somewhere rural to hospital, or from city to city. We have this example from Milano to Zermatt, where it takes 4 hours by car and just 20 minutes by plane. And So that's our approach. And if you have if you do your math and your calculations, and then you double the cost, and it's still a business case, then you're kind of ready to have a real business case. So that's about how it goes in aviation, rather than squeezing out every cent of the potential. You rather calculate in reserves, and that's where we aim for. Maybe next slide quickly. There's another way or big reason why these aircrafts will become the standard in search and rescue and EMS transportation. It's called this golden hour. If a patient is heavily injured or is in critical condition, you should be in the right hospital within an hour. Then your survivability rate increases dramatically. And with our aircraft as well, we have today vast areas, and I don't talk only about the developing countries. I talk about as well about the industry countries like US, where 50 million people don't live in this golden hour area, or Germany, Eastern Germany, where there is a lack of emergency doctors. In Europe, there's always emergency doctor and a medical doctor on board. Where you lack these doctors, you don't have the people anymore, or the doctors anymore to supply help if it's needed. And these aircrafts, as they will be dramatically faster and dramatically more efficient, can provide help way better, and it will lead to more people to survive. Maybe next slide. That is a bit of a case base how we calculate these costs. So I'm coming really from the real operational side. So I know what a helicopter costs and how much they fly per year. So we calculate as well there with reasonable flight hours per year. We calculate with reasonable costs. And there are two ways. So you calculate up the cost that you have, and then you take comparables from existing helicopters and operators, and just add what you can think, and then you have this kind of reserve part. That's the gray area, and then you're still way better than helicopter, and already that increases the potential for operational cases, for business cases to build dramatically, not only in EMS area, but as well in just plain commercial helicopter flights. Maybe next slide. This is quickly a summary of the EMS part. So we are in all our very conservative calculations, and Air Zermatt operates as well ambulances. So I know both areas, helicopter and ambulances, very well. And we are even in Switzerland. We are competitive against ground ambulances, but obviously way more faster than these ambulances. And compared to helicopters, we are as well faster, but way more cheaper. So in that already in Switzerland, that will mean the helicopter operation, which is in Switzerland, there is a lot of helicopters flying around because of the mountains and so on. But even in Switzerland, you have about the 10-fold of potential. And when you go to Germany, you have about the 30-fold, 30 times the potential of helicopter transport today's only in EMS areas. And when we go to the next slide, we did as well the commercial calculations. Obviously, it's not only ambulances, it's as well commercial transportation. And today we talk about regional air mobility, urban air mobility. We talk about building helipads on top of roofs in the city where helicopter or these eVTOLs will land. No one or few people know that this is quite difficult to realize. Dominic, our partner, is one of the few who built probably the most helipads in Switzerland as a civil engineer. And you have to increase the strength of the building only to land on top of there. It's not just to put on a helipad. You have to make sure that the crash case is covered, and that means you have to make these buildings more strong. So we thought, let's take the helipads that exist. Is there a business case? Is there a potential to fly on the 2 days existing helipads? And yes, we took this east coast of America, and we were simulating about 10,000 journeys. Jasmine did it actually, from home to a helipad, taking your eVTOL to the next helipad, and then there take the car to the actually it was Boston. It was the Boston MIT to reach Boston MIT, and then we calculated from 10,000 different random journeys, where do you get efficient and where is the sweet spot? And actually, when you go to the next slide, that's the heat map that came out of it. So you see the blue part, that's about the 50-kilometer range, where a car, in our view, is still more attractive on existing infrastructure. Might change when you build up new helipads, obviously. And then the red part is where the airplane is more attractive because you are closer to an airfield, a real airport. And in between, there's a huge amount of area where eVTOLs will dramatically change the way that we travel. And we are not believing that you take the eVTOL every day, but it will kind of become like a taxi today. So when you're in your hometown, you usually take the bus or train or the public transportation in general, because or the tube, because it's obviously cheaper and efficient. You know how it works. But once in a while, when you're somewhere else, or when it's important or convenient, you take a taxi and you can afford it. So I would say in the developed world, maybe 50, 60, 70% of the people can afford to take a taxi. Whereas helicopters today, maybe 0.01% can afford to take a helicopter to be faster at a place, because nobody can pay it with a conventional salary. And these eVTOLs will, in general, change that factor towards more affordable flights in this area, because obviously, they're way more efficient, way less complex than helicopters today. So that's maybe to wrap up our approach. We focus on existing operations. We want to build something that can be used for life-saving operations, but as well for 2 days operators of helicopters. I would like to give them the best tool, or I would like to give my colleagues the best tool potentially, where they can fly around, and obviously with all the advantages of these eVTOLs, like less noise, like more safer because of the multi-redundancy of these electric systems and computers that can go that way. So that's basically our mission we are on. And yeah, Jasmine, do we need to add something?
I think that covers it nicely. Yeah. I guess that concludes the presentation part. So thank you very much.
Perfect. Well, thank you both. That was really that was very interesting, and it looks like we've got a bunch of questions. I'm going to start cycling through them. Bruno, hopefully I don't butcher your last name, Morthammers, asks, Thomas, as an expert in helicopter-based rescue missions, do you foresee a future for eVTOL aircraft in this scenario? And followed by, will hover in windy conditions ever be stable enough to do this in such dangerous terrain? And I know we've spoken about that before. So what do you think?
Yeah. I think about 80–90% of EMS operations can be taken over from these kind of aircrafts. There will be a 10% part which might still be taken over by a helicopter. There is one, or there are two things to mention here. These aircrafts will not be helicopters. They will be planes that can take off and land vertically. So you have to be way more thinking ahead and having your approach line, having your proper approach. In our specific case, it's this transition corridor, or in every VTOL with a wing, it's this transition corridor. This is basically the case, but you can land, especially our aircraft, you can land everywhere. And the tilted wing is, by the way, not a negative part for gusty condition. It's even the opposite. The wing, the aircraft has, for example, has way more efficiency in the yaw control. Why? Because the yaw is made by the ailerons. So you have about 2 to 3 times the efficiency of a tail rotor of a helicopter, and you don't have the general load of the counter-rotating moment of it. So as well, you will have no LTE condition with these aircrafts. And the wing as well, that's the big advantage of tilt wing aircraft. The wing is completely covered by the prop stream, so you are not that eligible of gusty conditions. So the aircraft can be totally safe, or will be actually in some cases even safer than today's helicopters to fly. There is another element of it. Obviously, the reaction time of an electric control system, like today's on drones, they're way more stable than it is with a helicopter manually controlled, and we see that already on our eVTOL demonstrator. So we did 500 flights so far, and we did test it in up to 25 knots wind already, tailwind, front wind, side wind, turning into the wind, or doing 360s in the wind, and that's actually quite simple. And the aircraft itself, the control system that actually Jasmine developed, is genius. It's way more stable than I could ever think of hovering myself. So yes, they will take a lot of applications of the helicopters for sure.
So we have, thanks for Thomas for that answer. We also have Mike Hirschberg, who's asking, originally the operational concept images showed 2 propellers. Why the change to 4 propellers?
So yeah, that's a bit of a trade-off. So we were coming from electric flight, and electric flight has to be the most efficient way, and 2 propellers with big propellers are way more efficient than many small propellers. So a helicopter, there is a reason why a helicopter looks like it looks like, because it's more efficient to have a big propeller above you than having 18 propellers above you. So, and that's the same here basically, because you are limited with battery technology. You have to make sure that your aircraft is the most efficient that you can produce. Now there are disadvantages as well, and that comes from regulations, right? So you have to make sure, or you have to be able to show a 10⁻⁹ catastrophic failure. And obviously, if you have 2 propeller and 1 fails, you're going to lose your aircraft. However, if you have 4 propeller or more, that adds more safety on that side in the case 1 propeller fails. So that is a little bit going towards the direction of the eVTOL development, where we want to be able to, and as well, obviously, for operational reasons, that I can be able to mitigate that risk of losing 1 propeller. I lose a little bit of efficiency, but on the other side, I can prove this redundancy in the propulsion system overall, actually.
There's an additional benefit that we saw with the demonstrator, which is that the smaller props mean you have a higher prop wash velocity, which actually improves the handling characteristics.
Perfect. I also see other questions around the propulsion system. Can you talk about how agnostic the concepts are? In other words, electric, hybrid, so on and so forth.
So a concept like this really needs to be at least partially electric for efficiency. One of the big problems that the Canadair CL84 and XC142 had is that if you're building them with conventional turbines, they have to be enormous, and you're building in enough power to lift the aircraft vertically and additional power for redundancy. So if one turbine fails, you can take over with the other one with a cross-linked shaft. Same arrangement as is in the V-22 Osprey. And with electric technology, we can put in electric motors that have the power that we need, and then enough batteries for the vertical phases of flight and reserves. And then the additional power that we need for cruise only has to be delivered at a lower rate. So we can use either more batteries with a lower C rating, or a hybrid power system where we have a range extender on board. So I would say it's a very important step for the efficiency and particularly the cost efficiency of these aircraft.
Perfect. Oops, sorry, go on.
And I think that's one of the why it doesn't make sense today to equip a helicopter with an electric propulsion system, because you always need 100% of your energy for hover, for cruise, maybe 80%, but you always need that. And then you get to the limits of your batteries, so you have these lifetime problems, C rate discharging problems from 100 to 0, and your cycles that you can draw out of it until your battery are at 80% is at limit. And with these tilt wing or convertible aircrafts, you actually can mitigate that with this very small time of taking off and landing, where you draw the battery power. But it basically, like today's electric cars, the batteries are totally fine, because you usually just take a couple of percentage of the battery and not from 100 to 0. That's what they make it, or just in occasional cases when you drive longer, you might do that. And that's the same here. So if you, and that's why I believe as well at the beginning do it on hybrid systems for the cruise phase, because as well the infrastructure is not there. You need to be able to, on rescue missions. So we have days where we fly one rescue mission, but then we have the days where we fly 15 at one after the other. I can't recharge my aircraft then. I have to go to the next one, and I have to be able that you can refuel like a helicopter today and go to the next one. Or I get a call on the mission, and then all of a sudden you have to go to the other mission because that's a life-threatening injury of a patient, and then you have to be able to compensate that at least until the batteries will become good enough to compensate for that. And then eventually as well helicopters become electric. But right now this is the huge advantage of these convertible aircraft, that you can basically combine these two technologies.
There's also another question about today's helicopters will be able to fly the Dufour Aerospace aircraft. How do you foresee the transfer from a helicopter pilot license or fixed wing pilot license to flying your eVTOLs? Will it be easier for helicopter pilots, or would you say the controls are different enough so that having helicopter experience does not pose a real advantage?
I think the control system will be made that you can fly these aircraft as well, very simple with a pilot's license. There is a pro and con, and that comes as well. Experience made the US Air Force or Army, sorry, with the V-22, and that's what I meant before. If you say, well, I have a fast helicopter, I can turn it around and on the place and just going on, that is going to be a critical case. So if the pilot is aware that no, it's a plane, you have to do your proper final, you have to you be sure that this is going to work, and then at the end you hover. That's another approach, and basically the US Army made it more safe afterwards because of that, just to change the mind. So it's rather how to fly a plane, and in the end you hover, than having a fast helicopter. It's not a fast helicopter, I think, even though it can take over many parts, or I would say 80% of that work.
Perfect. I actually have two questions. I think they're more for Jasmine, but there was a question here that says, Jasmine, I see that you have DO 178C expertise. What is the amount of embedded software line of code do you have to certify with ESA, A, or FAA, and how hard is it to design? The other question, I guess I'm wrapping into that, is how hard was it to design the transition from hover to forward flight?
Okay, so first part of the question, we're certifying under EASA, and the number of lines of code, it's too early to say, but there will be a significant number of lines, some of which will be DAL A, so we do have quite a bit of work ahead of us. The second part of the question, how hard was it to control the transition? It's clearly one of the bigger challenges in an aircraft of this type, and it's taken us a few years of studying it and doing subscale modeling and simulation to get there. In hindsight, it doesn't seem that hard, but I would say that the process was not trivial.
I'm sure it is. I do have, okay, so we have a question from Graham, who wants to know how the tail thruster works. I'm assuming, well, anyway, I'll let you answer that.
Yeah, the tail thruster on the VTOL Demonstrator is a pair of impellers, one providing thrust up, the other down, and it has a fairly neutral center of gravity under the main rotors, so we provide that balanced thrust.
And another good question for both of you is, obviously this is an eVTOL, but it can also be considered as an ESTOL, or an eSTOL or an ECTOL, is that correct?
Yes, so the Aero 3 aircraft, and that's obviously one. So you see the concept of it, and there is it's kind of my helicopter heart who is speaking for that simple, and having somewhere kind of a tricycle gear, or two wheels in front and one on the tail. And that is actually not very favorable for conventional or short takeoff and landing. And that's, by the way, of the CL-84 and as well Aero 3 aircraft, one big advantage. It has CTOL and STOL capabilities. It flies super well in STOL. That's why because the thrust goes behind, or it passes the elevator and the side rudder. So you have, even with a very small or low speed, you have full aerodynamic control of your aircraft, and you can land it STOL or CTOL as well. So it will become a tricycle gear, landing gear, and it makes totally sense if you have, like in America, where you have a lot of small airfields to take off and land. You can save energy, and that's always a big favor of it. So this aircraft is as well usable for these kind of commuter operations, as it is as well. It has up to, it will potentially have, especially in CTOL, there the energy that you can basically draw as well is way bigger. So you can have probably up to 7 persons in that aircraft.
Yeah, actually, that's a good point you're making, because the original question said, can you increase the payload if it's used as an STOL or a CTOL? But you can only, well, you can not only increase the payload, but of course, I would assume the range, right, and the efficiency.
And don't forget, you have the power of a VTOL, of a helicopter to hover on your wing. So that aircraft is dramatically powerful. It will climb out like a homesick angel, as we say. So that it will have way more power than today's aircrafts. That as well means you are way earlier, higher up in the air. That means prevention of noise on the ground as well. And you have in the transition corridor, you need way less power, because as soon as the wing tilts just a little bit, 10-15 degrees, the power draw for flight is dramatically going down, because you produce your own lift with your wing. So you don't have to accelerate with your propeller on the tail until the wing starts to lift something at some point at speeds. But actually you produce your own lift, and it flies right away.
There are two great questions I want to make sure we ask within the last 10 minutes. One of them is if one motor fails, how do you counter the reaction torque from an uneven number of motors? Can you hover in this condition, or do you need forward velocity to counter the movement of the moment with the rudder? Excuse me.
No, we're designing it to be able to cope with a failure of any of the lift systems or motors.
Okay, good.
And there maybe quickly to add as well, there it will be kind of a helicopter operation. It's called this Cat-A procedures on twin helicopters. You basically take off and land like a Cat-A helicopter, and you have your decision point where you can go around and go into cruise flight, or you go back on the landing site. So this is the concept. Every helicopter pilot on twin engine helicopters understand that. Every helicopter operations knows how that works.
Perfect. The other question is more around the battery technology. How do you deal with technological change with an electric aircraft where batteries and other systems may be evolving at a much faster rate than conventional technology? Doesn't this present a challenge when it comes to recovering development costs?
Development costs. Well, we are designing the vehicle to be certifiable with the technology available at the start, and it will have a certain level of performance, and we're comfortable that performance will be very much good enough to sell. And then, of course, as technology improves, we can update the systems. We can offer, as part of our Power by the Hour service package, we can every few years, certify and install a new generation of battery technology to improve the performance further.
Perfect. I have a question here. I'm not sure if I understand it, but do you have a level attitude for acceleration or deceleration? I'm assuming it's altitude, which would seem to be an advantage in medical transport.
Can you read that one more time, please?
Yeah, it says attitude, but it's probably altitude. Do you have a level altitude for acceleration and deceleration, which would seem to be an advantage in medical transport?
Yeah, we do. We can. The flight envelope includes full forward and back transition with any climb or descent rate within a range. So we can do forward and back transition while staying at a level altitude and a level attitude.
Gotcha. Perfect.
Towards EMS, it doesn't matter so much, because you have your transition corridor where you where it should be in terms of speed and power, where it flies ideal. So for back transition and forward transition, and you basically take off and land, you have your climb descent rate like conventional planes, helicopters today have as well. And it depends. If you're here in the mountains, you have to climb very high, probably at 12,000 feet to pause the mountains, and then go to the center hospital on the other part of the valley. Where when you're maybe in the Boston area, it's probably quite flat, and you don't go much higher than 2,000 to 3,000 feet, maybe.
Okay, and just actually, it was Graham Warwick who actually asked the question, and he's telling me it's Fuselage Attitude. So that was the question.
Yeah, we can keep the fuselage completely level during forward and back transitions. It's probably
another question was on. Oh,
sorry, it's probably also worth pointing out
that
we can perform back transitions while descending, which is something that not all convertible concepts can do.
Another question that was asked is, have you considered distributed electric propulsion system like Lilium Jet, for instance?
Well, to some extent, we do have distributed propulsion in the sense that we have enough lift systems that we can continue safe flight and landing after any single failure. But beyond a certain point, you get no further benefit from that. So we've tried to optimize the performance of the aircraft against the redundancy and resilience against failure. But I think having a large number of lift systems is not beneficial.
Perfect. And I think we pretty much covered all the questions. There was a question about whether it was all electric or hybrid electric powered, but I think you've actually answered that. Do you want to add anything to it?
Yeah, so the aircraft will be modular. So you will have it is basically a pure electric aircraft, but you will have kind of an area where you, at the beginning, potentially, especially for helicopter operations, you will have a turbine with a generator, an inverter on it to produce electricity on cruise. But it can be another source for very short applications. We have a couple of these ones where 3-4 hospitals are just within 3-4 minutes distance between each other. There, a pure electric aircraft makes totally sense, and then that part will be you can add batteries on it to fly fully electric. Or as well, Thomas Zeiler, he was last 5 years. He was basically in a company where they used hydrogen systems, fuel cells in trucks and other ground transportation things. So as well, at some point, that might be the right thing to use for longer flights. So it should be like the aircraft as well, as Jasmine already pointed out. The key element is that the aircraft itself is efficient. I might as well take a taxi comparison. Today, you don't take the old Hummer Jeep to do your taxi drives, right? So you take the Toyota hybrid car. Why? Because it's more efficient. So if the aircraft is efficient, you always have, even if the battery technology evolves and eventually it becomes fuel electric, you need less batteries or you can fly longer. So the key is really that the aircraft itself is as efficient as possible.
So we're coming up on the hour. I don't know how many more questions we can take, but there was, I think, for maybe the last question, that might be a good one. What makes you stand out from all other companies in the eVTOL space?
I think having the operational experience with Thomas that we have is really something that distinguishes us. I mean, I very much enjoy the technology that we're working on, but without his guidance of what the requirements for the aircraft are, we would probably not be able to build the right product.
I would add there that I see a little bit different. I think that's obviously one element, but having the technology and proven that it is flyable in man-sized aircraft, and how many of our competitors showed transitions, right? How many they show nice aircrafts that might hover, maybe some, not even all of them. But first you have the technology, and I think that's one advantage, that we know how to make these convertible aircraft fly. That's something that we can as well scale up or down, depends on what the needs are, because the tilt-wing aircraft are the most efficient aircrafts. And second is, I guess, I was as well CEO and CFO of multinational pharmaceutical companies for some time. I built supply chains and so on. And one element that divides us from us is we're about 10 times more efficient cost-wise than all the others. So if I see how much money goes into that industry and how much comes out compared to what we deliver, I'm proud of my team that we can do that at factor 10 less costs so far. All of the projects that we did so far, and we might continue that. So maybe it comes a bit of because of the seniority of the team as well, that we do some mistakes less than others, like some do already, having a prototype number 3 and 4 and so on, and they realize, oh, it's not the right thing. And many of them will realize at the operational side as well that it is not the right thing, to be honest. It will have difficulties to be operated in high density operations where you load and unload hundreds of people every hour into your aircraft. And if you want to see that, how that works, everyone is happy to visit Air Zermatt in Zermatt, in this valley, where that happens frequently when the roads are closed. So I think this is something that these points that differentiates us from I would say our competitors.
So I want to make sure that we're okay on time. I want to be mindful of everybody's time. It's after the hour. We still have another question. Jim, Mike, are we okay asking this? I'm going to put you on the spot right here.
It's really Thomas and Jasmine's time. We still have everybody's still sticking around. So.
Good. Okay, so in this case, we do have a good question. Is why did you decide to go with a tilt wing as opposed to tilting rotors with a fixed wing? And then the following question to that is this because of the beneficial behavior of a tilt wing in gust conditions and STOL capabilities?
Yes, both of those things. I think there are a number of advantages. So a tilt rotor has an issue of download from the prop wash onto the fixed wing. You're losing some of your thrust to that, and you're generating wasteful vortices underneath. And then as you start to go through the transition, you really don't have a good angle of incidence on the wing until quite late in the process. So your rotors are having to do dual work of holding you up with lift and accelerating you forward into the transition. And with a tilt wing, we immediately offload some of that lift work onto the wing as soon as you start to tilt it. It always has a smooth airflow over the wing. You have very few losses and very nice handling characteristics. And because the wing is always pressurized, you do actually have less vulnerability to gusts as well. Oh, I'm not hearing you, Nicholas.
Yes, that would be because of that darn mute button. Alrighty, so what is the scale of the demonstrator compared to the operational concept? Is it something like 1/3 or 1/2 or what?
It's somewhere between those two values, between 1/3 and 1/2.
The other question around that too was, what is the material of the structure?
Of the VTOL demonstrator?
That's my assumption, yes.
It's mixed material. It has composite, glass fiber, and yeah, aluminium. I would say that the basic structure is a composite monocoque.
And
Gotcha.
as well, the next test aircraft. So we want to fly as much as possible. So there are coming more of these aircrafts into the test flight regime, and they go more towards composite carbon kind of fuselage, getting more stronger. We want to test them through early. We want to do more hardcore tests with these aircraft, so flying them in all kind of conditions and back and forth, and however stress we can put on them, the better. So that's our plan, to tune the control system, but as well to show and develop the behavior of the aircraft, because this transition corridor obviously is very important. And CL-84 as well, every pilot loved this aircraft. It was so simple to fly, even manually. You didn't even need a control system. You could fly this aircraft by hand, manually. And that's our goal. We have to have an aircraft that is so simple for every helicopter pilot like me, because that's where handling characteristics comes, right? And maybe another element of it, we're talking about certification and risks and risk mitigations and so on. What we forget with that is that there are only about 13% of the accidents are related to the technique, to the mechanics, to the aircraft. 83% are related to the operational causes. And that's where you want to have an aircraft who has sufficient power, who can take you out in a critical situation, where you have enough to climb out, where you have enough power to go around, where you have enough things where you can basically have a good aircraft to compete with, or to compile these kind of risky situations that every helicopter pilot gets into it many times in his life.
And speaking of which, perfect answer. When is the full scale going to fly, and have you started building it?
We have not started building it. We are finalizing the design, and we're hoping to start work on the experimental prototype next year. As for the certification path, we have a few more years ahead of us after that.
Perfect. And actually, a really good question. Do you expect any major aeroelastic issues? I can re-say that. I can say that word again if you want.
No, because we've been analyzing it very carefully for the aeroelasticity and the resonant frequencies and so on.
Perfect. I think I've asked all the questions that were asked. Let me just scan one more time. Okay, yeah, this one I missed, I'm sorry. Can you tell us a bit more about the simulation models and aerodynamic tools you used in trading off conceptual designs?
Actually, one that we used in the early stages of the project for conceptual work was X-Plane, and it's not widely used in the aerospace industry, but I'm a big fan, and it really allowed us to quickly evaluate many different designs. I think if you put it in front of a professional aerodynamicist, and I have, they will laugh at you. But in terms of quickly analyzing concepts, it's very valuable, I think.
And I believe, by the way, one eVTOL or UAM aircraft made it on X-Plane not too long ago. I can't remember. I think I saw that somewhere in the news. And I think that's it. So I think we pretty much covered all. Oh yeah, there was one last question again. I'm sorry, I missed it. Does it occupy more space than a helicopter?
It is basically designed to take over EMS helicopters rooms. So expect it to be around an EC-135 and Bell 429 fuselage or cabin space. So rather bigger than most other concepts. exactly because of that. So if you load people in it, if you load patients and medical equipment and so on, you need to have space, and that's where we are going to design it for.
Two questions here. I'm sorry, Jasmine, did you want to add something?
No.
Oh, okay. How will cold climate affect battery performance, and who will operate these services, you or an EMS company? Perfect question. I was going to end with that one.
Yeah, so so all of our competitors are thinking of operating them, right? So they design them, they build them, and they want to operate them. I am CFO. I was CFO of Air Zermatt. I'm since 25 years flying that. I'm the operator. I know what operating these aircrafts means, right? And no, we will definitely not operate them. We built for all the others who have who wants to operate them. So our customers are all the helicopter and air companies who basically know how to operate in their specific environment. And we built the best plane ever that you can use for that. So we will stay at our, we will keep our, we are building them and not operating them. Yeah, so that's coming from 25 years operating these aircrafts.
Yep, know your limits, know what you want to do.
There was also a question there. Sorry, there was also a question there about cold climate and batteries, and it is definitely something that we are aware of and will be mitigating. So it shouldn't affect us too much.
Yeah. Plus over there you have a nice varying range of cold and hot weather, so I guess you guys are ideally placed for that. There was also another question. This might be a little bit trickier to answer, but when discussing heliports on buildings, do current insurance standards cover the use of electric aircraft and their attendants differing fire hazard from jet fuel from top of building heliports? So I can ask the question again if it's makes it clearer.
Yeah, I know what you mean. Obviously, like in cars as well, there's today this issue that firefighters, for example, or sites, cars especially, fire brigades have to cope with these new kind of burning situations. To be honest, flying with electric planes already, I don't see that much of risk in general. Of course, they can burn, and if they burn, they burn. That's true. But talking about, so we're, especially in aviation, we are sitting all over Molotov cocktails, right? And flying around on Molotov cocktails. And then we are talking about a burning battery. I mean, I really don't see that big problems to come in, or that this is a huge problem of these electric planes, to be honest, because it's very seldom that an electric plane just explodes, right? So it burns, and when it burns, obviously you have to mitigate that risk. Again, something that is a bit an argument why I don't believe in that every single roof deck will have a helipad in the next 5 years. I'm rather conservative in this judgment. I think we are rather into the in the existing situations. Even there, it might be a challenge to fulfill these regulations.
Yeah, you know, just one very quick bunch of numbers I gathered from my past experience with EVs. 500,000 cars burn up in the United States, right? Gasoline cars, and about 130 to 150,000 gasoline stations go up and never a word in the press, but one electric car goes up and that's it. Everybody talks about it. So I guess that's really it. Yeah, and same thing with redundancies, electric motors. Well, we know they're much more efficient and reliable and all that kind of good stuff. I think that's it for today. We've asked all the questions. I wanted to thank you guys for coming up and showing up from Switzerland today and introducing Dufour Aerospace. And thank you, Jim and Mike, for hosting this amazing eVTOL writers group. And thank you, everybody, for asking the questions. Sorry if I didn't get to every question. And sorry, Graham, for not understanding attitude instead of altitude. I mean, altitude instead of attitude. So thank you, everyone.
Great.
Great job. There are a lot of typos, by the way. Huh?
and by the way, happy to answer as well. To reach out to us if there are questions that go further. We're happy to answer as much as we can.
Very good. So if I get additional questions that comes through my email, I can forward them to you. Or if you want, you can, before everybody kind of drops off, if you want to drop your emails in the chat box to the audience, you could do that as well. Thank you, Nicholas, for moderating, and our incredible thanks for Thomas and Jasmine for your participation today and being a good sport and going a little long. I think you guys are doing some wonderful things and look forward to following your progress as you get through it. And again, if there's anything that we can do here with the Vertical Flight Society or the eVTOL Writers Club, or sorry, not Writers Club, Writers Group, I'll be happy to partake in and help you out as best we can. I had posted earlier some resources that I'll put up again real quick. So if you're looking for additional eVTOL online resources, this is what we offer. We've got evtol.news as well as our social media sites. So go ahead and go visit those if you're looking for some additional resources. And of course, next month, less than a month from now, actually is our annual forum. So if you have the opportunity to come visit us from October 5th to the 9th, please do that. Look forward to seeing you all there. And just one last thing is we have our next interview next week, and that will be with CS Communication Systems. And look forward to seeing you all on that webinar as well. So thanks again to Jasmine and Thomas and Nicholas for moderating. It was a wonderful show, and we look forward to seeing you down the line. So goodbye, everyone, and thank you.
Great. Thank you very much.
Have a good evening or day. Bye.
Oops. We'll talk right after this, I guess.